Hi everybody, I wanted to review a problem with you from section 8.5. It's number 5 in the homework set. So it says the following: a simple random sample of 26 filtered 100 millimeter cigarettes is obtained from a normally distributed population, and the tar content of each cigarette is measured. The sample has a standard deviation of 0.22 milligrams, uses 0.05 significance level to test the claim that the tar content of filtered 100 millimeter cigarettes has a standard deviation different from 0.35 milligrams, which is the standard deviation for unfiltered king-size cigarettes. So not only are we going to answer the parts that are in the homework problem, but we're also going to think about this from a perspective of doing the entire hypothesis test on a test or a quiz. And I want to show you what I would expect on a test or a quiz. So step 1 will be to start with our hypotheses. And we'll have H0 and H1, our null and our alternative hypothesis. And what we're going to do before we do this is to identify some important information that we need for the problem, like our sample size. I always start with sample size because it's the really important part. It'll help me figure out where everything else is. Part of the hard thing about these problems is identifying what the variables are. Finding the sample size is pretty easy usually. It says a simple random sample of 26 filtered cigarettes. So N is 26. If I get my pen to write. There we go. And then I want to find what's the standard deviation of that sample. And it says the sample in the second sentence, the sample has a standard deviation, which is S, of 0.22 milligrams. Okay. The other number it gives us is at the significance level. We call it alpha, is 0.05. We'll talk about that in a little bit. And we're told that we're testing the claim that the tar content of the cigarettes has a standard deviation different from 0.35 milligrams. So not equals will go in the alternative hypothesis. That means different. Remember, our null hypothesis always has equals in it, always, no exception to that. And the test is about the standard deviation because it said the standard deviation is different from 0.35 milligrams, which means that our null hypothesis also has to have the same symbol. It's the population standard deviation, sigma, and it also has to have the same number to the right of the equal sign, 0.35. Finally, let me change my pen color. It says we are testing the claim that the tar content is different from 0.35, which means that our alternative hypothesis is the claim. And let me bring back my black pen. Okay, so that's step 1. So step 2, let me label this as 1. Step 2 here, we will draw the actual chi-square distribution. That's what we're going to use to run this test. So chi-square, it's pronounced chi like a kite, not chai like chai tea. Chi like a kite. And we have a two-tailed test because we have the not equals in the alternative hypothesis. Okay, so I'm told that alpha is 0.05. That means that's the area in the two tails. I want to find out how much area is in each of these tails in my little sketch here. So I take alpha and I divide it by 2. To take 0.05 divided by 2, which is 0.025. And that means there's 0.025 in my left tail and 0.025 in my right tail. Okay. In the center, then, there has to be 0.95. I always like to label all the regions in my sketch because it helps to visualize what's going on. I strongly recommend draw a picture, especially on the test, on the next exam or the final. The more you can show me of your knowledge about the problem, the more points I can give you. So the next thing we need to find is our chi-square values. We will have two chi-square values, and they are critical values. So we'll call them chi-square of alpha over 2 because they're critical values. Think of critical values as the values that separate, let me just change my pen for a second, that separate the rejection region, which is the tails, that's where I reject. Reject on the left side, reject on the right side, from the fail to reject, which is in the middle. All right. So we want to find those two numbers here. So what we need to do, let me just change my pen one more time. We need to go to page and label our chi-square values. And let me change pen color again, so maybe it'll be easier to see this. My chi-square left, let me start with the right, is 40.646. And our right chi-square, sorry, our left chi-square is 13.120. Please notice that our chi-square starts at 0 and it increases as we go to the right. So depending on our test statistic, what we calculate will determine what our decision is. Let's move things up a little bit and work on step 3, which is our test statistic calculation. So for chi-square, our test statistic looks like this. It's again a chi-square value. Sorry. And it's n minus 1 times s squared divided by sigma squared. We know all of these values. We know that n minus 1 is 26 minus 1. S is 0.22, so I'll have 0.22 squared. And I'll have sigma squared 0.05 squared. And when you calculate that, you'll get that chi-square is 9.878. Now we have two ways to make our decision. We can use what's called the critical value method, or we can use the p-value method. Now for the test or quiz, I always recommend to use the critical value method to make the decision. All that's going to be is I'm going to look at my test statistic right here, which is 9.878, and I'm going to find where would it be in my sketch. So if you see, it's going to go here in the reject region because 9.878 is between 0 and 13.120. So if I use the critical value method, my decision is to reject the null hypothesis. Now we have another way we can make this decision, which is called the p-value method. The p-value method, if you look at the next page, I've included the handout with this video, you'll see that it gives you instructions from the textbook to help you figure out how to use StatCrunch. We don't have StatCrunch when we're taking the test at the testing center, so I basically tell you to use StatCrunch for the homework. You can always use the critical value method. You could see we did that to make our decision to reject the null hypothesis. So finally, our conclusion is step 5. Before I do step 5, though, I want to move up a little bit in this page because my decision was to reject the null hypothesis. I'm going to cross out the null hypothesis because I'm rejecting it. So what's left? The alternative hypothesis, but more importantly, what's left is the claim. So the conclusion will be all about what the claim is. There is sufficient evidence to support the claim. That, and what was the claim about? That the tar content has a standard deviation different than from 0.35 milligrams. Let me move it up a little bit. Oops. So it just mimics what was in the alternative hypothesis. And we're done. I hope this helps you. I would use this method when you take a test for me, whether it's exam 3 or the final exam. This is what I would expect you to do. Bye. 3 of this problem from your textbook. So it's on page 428 of your textbook or ebook. You can see using technology gives you help with using either the TI 8384 or StatCrunch to help you make this decision. Handout here, and we're going to look at the chi-square distribution table. So we need 2 pieces of information. We need the degrees of freedom, which is n minus 1. And if you remember, we found that n was 26, so 26 minus 1 is 25. That's the row we're going to use here in the table. And the column will have 2 of them. Let's start with the area to the right of the critical value because that's the way this table reads. So the right side little tail area was 0.025, which is this column right here. If we join that row and that column, you'll see that the answer, and I just covered it, let me do that, is 40.646. This table is symmetric, so one trick you can use is you see that that's the 3rd column from the right, where we found the right chi-square. Well, you can start on the left side and go 1, 2, 3 in to find the left chi-square. It's symmetric.